Great, so I want to talk about kind of some vignettes of what I think might be unlocked by practical zero-knowledge proofs. So we heard a little bit yesterday about how zero-knowledge proofs are kind of ahead of schedule. Progress has been going better than we expected. And so I think that gives us license to dream a little bit about what the future might look like. And I'm hoping to suggest a little bit of that for you today. So just to review, digital signatures are kind of what got us started. Digital signature is a type of zero-knowledge proof. But even with, by putting them into a consensus mechanism like blockchain, they don't take us all the way. So what do I mean by that? We're forced to program with them rather than in them, right? So we use digital signatures to authenticate messages in a chain or to construct a tree of trust in like a certificate authority system or a PKI. People love using them, but they lead to complex constructions, chatty protocols. Blockchain is a kind of chatty protocol, right, where we have to wait for light to get around the world and round trips to be completed in order to know something is true. And we have some limitations on our security model and our privacy options. And in some sense, it always comes down to somebody storing a secret key, even if we shard it. And there's a hypothesis that perhaps that requirement of kind of a bearer asset or protecting a secret key might prevent things from ever really becoming mainstream. And I think that zero-knowledge proofs, one of their greatest promises is to kind of allow us to break that requirement. So a zero-knowledge proof is a programmable signature. The idea is we have a normal signature algorithm where we have a secret key, a public message, and a signature algorithm that everyone knows that's applied to those inputs to produce a signature and a public message, and then it's verified by a counterparty, such as by the chain. A zero-knowledge proof really just lets us replace that secret key and public message by arbitrary private and public inputs, and it lets us run any program we like, not just a fixed signature algorithm, produce a proof instead of the signature, and again, public parts. And initially, ZKPs were sold as kind of probabilistically checkable proofs, which sounds bad. But when I say it's probabilistically checkable in the sense that you might be able to produce a false proof, just like you might get lucky and guess Satoshi's keys, it feels a lot more comfortable, right? So it's probabilistic, but it has similar security properties to a digital signature, which are great properties. And what's exciting is that zero-knowledge proofs are not just programmable, but they're becoming rapidly more programmable. We've seen them used in rollups, and that has driven the development of the technology, but it's also now possible to do crazy new things like put 100 million parameter AI models, do computationally intensive things inside of proofs, to do email, to build games. And moreover, there's been a lot of great tooling that's come out to make them easy to program with. You can write your circuits in Python, in JavaScript, or a number of special languages that have been created to make life easier for you. Technically, in terms of the amount of information and computation we can fit inside a proof, we're in a situation where progress is not slowing down. It's going extraordinarily quickly, and I'll say a few words about that in a moment. And so that gets us thinking about what happens when zero-knowledge proofs are as easy and as fast as we can hope, right? What can we build? So one thing that's near to my heart as a builder of zero-knowledge machine learning is kind of floating point operations per proof. How many times can I add and multiply inside of a proof? And what's happened crazily in the past year is that we've gone from a limit of around maybe 100 or 1,000 operations. Really, these are fixed point, but you could think about them as floating point operations in a proof, to something more like 100 million or 200 million operations inside of each proof. And this is just the code to our repo if you want to check it out. And that means that I have reason to expect that this progress is going to continue. Eventually, it's going to slow down, but we can expect we can do a lot of computation inside of a proof. Another way to think about it is not just computations inside of a proof, but how many proofs are happening. And one ratio I like to think about is proofs per blockchain transaction, right? So a signature is a zero-knowledge proof, right? So that means that we're always at 1, right? Every time I submit a blockchain transaction, I have to sign it, and that means there's 1 proof per transaction. As we start to get into rollups, we can think about 10 or 100, maybe on the order of 100 or maybe more, proofs that are kind of, or sub-transactions that are computed into a proof and submitted to an on-chain transaction. We heard a little bit yesterday about ZooPass, which was an application that uses zero-knowledge proofs developed for Zuzulu, and that was interesting because I would say it's sort of on the order of 1,000, where you might do 1 blockchain transaction to link an address or to pay for a ticket, and then you use your zero-knowledge proofs for all kinds of things. I mean, I went to a club and used a zero-knowledge proof to gain entry, right, during that event. So that already starts to be, well, a lot of proofs that don't really very often have to connect back to the blockchain, because much of the time we don't really need consensus, we just need kind of composability. We just need ability to transitively trust what happens. Okay, so where are we going for that? We're still at this sort of 100,000 thing that we were at a year ago with flops. This is more of a social problem. I mean, it is a technical problem, but it's also a sort of a social dev tooling and efficiency problem. You know, figuring out the use cases that cause more proofs to happen per transaction, figuring out the abstractions that let us compose them. So I'm going to say, you know, maybe 3 years tops before we get to a world of 100 million, 1 billion proofs being computed per blockchain transaction. And that's a very different world. And I sort of want to invite you to think about what the world's going to look like when we get to that point. So by practical zero-knowledge proofs, what do I mean? I have a couple of desiderata or requirements. I want there to be reasonable memory usage, fast computation. One metric for that is it's fast enough to run AI models. Another metric is it's fast enough to do on-device proving for privacy. If I want to do a decentralized Face ID using a zero-knowledge proof, I'd like to be able to run that on my phone. We're not there yet. I think we'll get there soon. I think on-chain verification is critical. I would say otherwise the epistemology is obscure. What I mean by that, one of the challenges, if there's 1 billion proofs per transaction being created, if there's a ton of proofs being created, it's hard to know. We know that they're true, because zero-knowledge proofs are like a language of truth, or the true language, as Brian or Barry were saying. But we still need to have some kind of global schema to understand what we've proved, like to orient ourselves in that world. And you know, on-chain schemas and on-chain verification is probably going to be a very important way to understand that something has been proved. And we want it to scale to 1 billion proofs per on-chain transaction, which again is sort of more social. And we want it to be easy enough to use that you don't need a PhD in cryptography to implement them. Okay, so if we put these 2 factors together, we get kind of a 2x2 or a 2-dimensional chart. Flops per proof, proofs per transaction, and we have a couple of data points, ZooPass rollups, Ezekiel, our machine learning library, and we want to ask, you know, what's going to happen up here when we have this world of 1 billion, 1 million, 100 million operations per proof, 1 billion proofs per transaction, what kind of applications will exist there? I don't know. I'm going to offer 3 sort of quick vignettes that hopefully will stimulate ideas. So the first you could call composable constructed truth. So one way to think about this is in terms of autonomous worlds. There's a hackathon going on right now with Xerox PARC, Lattice, and ETH Global. And what is an autonomous world? It's a game. Game logic is a great place to experiment with cryptography logic because the consequences are low. So that's why a lot of experimentation is happening in games. It's a game that's not under the control of any one player, or more importantly, under the control of the game maker. Right? Players can add logic to the game. They can change the game, the way the game works, but not arbitrarily. They can change the way the game works with a substrate of kind of digital physics, some kind of base rules of the world upon which they can build. Not so different from the base rules of the economic world that we experiment in with blockchain. The issue is that to make a fun game, an interesting game with a lot of physics in it, it's tough to implement that in the EVM because of the restrictions on gas and how much computation we have. And so the solution, one solution is to do it on-chain, but accelerate it with off-chain proofs. Accelerate it with ZK. We can do things like have the physics engine run in a proof, right? It's just a bunch of matrix multiplications. Create NPCs that can exhibit intelligence and even move between games. And have AI judges, like someone is deciding whether a picture that you drew satisfies this AI god. That's something we've seen built. Or you have a recipe, you're trying to create a cooking recipe, and the judge decides whether it thinks it's delicious or whatever, right? And so these are really fun, but they're also a way to experiment with the crypto system that surrounds the mixture of proofs and on-chain transactions so that, for example, we don't have problems with reversibility. So on the other hand, in the digital world, in our world, not the autonomous game world, but the world we live in, it's getting harder and harder to know what is true, right? We have this unstructured web. It's vulnerable to misinformation. We have AI fakes becoming indistinguishable from the real thing at a rapid pace. And so this digital world can feel like a game without rules, right? Without structure and without the composability we might want. We can't take two things which we believe are true and use them to compute something new which we also believe is true. But as we were just saying, we have new ways to construct truth, to agree on the state of a constructed world, new ways to establish and publish legitimacy. And I think we're at a stage where blockchain has enabled us to sketch that future out, right? We have an idea of what we might want these things to look like, about how to structure information, but on its own, it's probably never going to be scalable enough to express everything we need it to express. So we see a lot of kind of things which are on the way. So it's like it's something which is not fully decentralized yet. It's an application. When you dig into it deep, most of it's running on a proprietary server. And that's partly because if we want to express something like social, or if we want to do public publishing, we want to do any kind of scalable truth thing, we're going to need a lot of transactions, a lot of block space. And so on its own, it's not enough. And so, of course, we might want to use zero-knowledge proofs to accelerate that, right? So in our world, not the game world, but our world, we also would like it to not be under the control of any one player or game maker, right? Economy creator. We also want digital physics in the sense that we also want some kind of structured ground, structured substrate on which we can build our abstractions and compose. We'd also like AI NPCs. Hopefully they won't be like the bosses in a video game. They'll be a little bit more pro-social agents, but we can create those. And the way to do it is also with on-chain acceleration by off-chain proofs. Okay, so next vignette is this idea of how can we use machine learning to give the blockchain eyes. It's really very simple. You take this signature algorithm with private and public inputs, and you replace the signature function with a model inference, forward pass of an AI model. And that allows you, once you've solved the data provenance problem, which is another problem we won't get into, to trust that the inference of a model, the proof of a model, was correctly produced. So the model ran as though it was running on chain. What can you do with that? You can give the blockchain eyes to perceive the world, so you can finally solve all those supply chain problems that were promised long ago. You can do a decentralized authentication. I like to think about it as kind of a 10,000 factor authentication that links you as a human rather than a field element or a secret that you know, or even a partial solution to social recovery, links you unseverably to your on-chain identity and to your digital assets, right? It's maybe measuring not just your biometrics, but something like a zero-knowledge proof of your location history, or that you didn't suddenly jump from one country to another. A more general way to put that is that it lets smart contracts exercise judgment. So kind of puts the A into DAO, lets a smart contract make a decision that has soft factors. That's not just is this condition, is this number greater than that number, but did this person fulfill their contract? Did this article say that a hurricane hit a coast? Something like that. And the input, outputs and architecture and parameters can all be private or public. You can try our software that's available now to to build with zero-knowledge proofs, if you're ZKML, if you're interested. And then the last thing I want to talk about is rethinking money as a coordination protocol. So in some sense, I feel like what we've done with cryptocurrency in general is to take this old model of I have so many tokens, I multiply them by the last price at which they traded, and that's the amount of value that I have. And this was a great technology when it came out 500 or 600 years ago, or maybe even older than that. But it's not necessarily the best technology today to think about organizing an economy. And I think we're seeing a lot of gaps in the functioning of money as a protocol. I gave a longer talk about this for the Summer of Protocols, which you can check out. But let me give you a quick summary. So one way to think about it is that really money itself is a zero-knowledge proof, right? So in my past history, I make a bunch of transactions. Maybe I issue an invoice, or I get a salary, and I get some credits. Maybe I buy something, I get kind of a receipt that debits that balance, right? And all my future counterparties don't care what I did to earn money or what I did to spend money. All they care is how much money do I have, right? They want a transitively true proof of that it's been properly reflected, that all of these exchanges have happened, and they can trust my balance, right? So money is a kind of zero-knowledge proof. Another way to think about it is that it's a compression technology that decides if you should be done a favor, right? I want another mango. Society, give me a mango. What society does is weighs all my good and bad deeds, right? All the things I've done for others and that others have done for me in the past, weighs them, summarizes them, properly composes those summaries, and makes a decision, like St. Peter at the gates, do I get the next mango, right? And we've gone through a history of technologies to do this. So one technology is banking, right? So maybe we started with a ledger technology, paper and pencil. Then we upgraded that to COBOL databases. And we're seeing some problems with this. If you know, this bank is one of the ones that recently was forced to shut down. So the bank does this job of collating all my receipts and invoices and deciding, do I get a yacht or not? Do I get a mango or not? I get a mango. OK. Then we came up with a decentralized way to do this that didn't depend on the banks. Also very interesting, but in some sense the exact same model, right? I have a ledger. I keep track of the inputs and outputs. And if my balance is sufficient, then I get to buy what I want. Then we figured out how to program that model, right? How to make it so that we had programmable money and we had more flexible set of infrastructure to do it. But there's still a lot of tokens in there, right? There's still a counting of tokens. And then I'm arguing that we can now do some new stuff with zero-knowledge proofs, right? With ZKML and other technologies. We can make more subtle and sophisticated judgments about this past history, right? Sometimes it feels like just a bank balance or a net worth, the technology that the bank does and which has been ported to crypto kind of unquestioningly isn't the fairest way to weigh my contributions to society and the contributions others have made to me. And maybe we need something that's more fair or more stable or more robust, right? And the interesting thing about this is that not only can we make more intelligent decisions, we can do something really crazy, which is we can take these numbers here, 500, 700, we can take all the numbers in the receipt and we can actually delete them if we wanted to, right? Because we already record all of the things that I've done, all the transactions that I've done. So you could imagine, and this is a bit dystopian, but you could imagine, oh, there's an AI, and what the AI does is it says, well, here's the list of all of the mangoes you ate, and here's the list of all the services you provided, and based on that, I would like to award you a mango or a yacht, right? Now that sounds kind of dystopian, and it is, except that, well, two things. One, we already do it, but we do it with this one-dimensional summary of our history, this bank balance summary. And secondly, there is this possibility now of making the AI that makes these decisions decentralized, right? So I don't think that's actually a good idea, but the point, again, is to kind of stimulate you to think about what might be a good idea. So really, we're in this world. We're sort of down here in our technology, and we're moving up. We're moving to a world where there's hundreds of millions, billions of operations, AIs that fit inside of a single proof, where there's a billion proofs being computed transactions, I think that there's some fundamentally new possibilities in terms of how we organize our economy and our society up in this corner, and I hope that you figure out what those are.